Okay, so when we're learning about normal distribution, usually what you might see is the question will say this variable x follows a normal distribution, or you might see something like this where you have capital letter X with your line, capital N, and then your Greek symbols. And what this means is that is your random variable. So whatever we are investigating would be X. That always means follows. The capital N means normal distribution. And then we have the mean and the variance. And that's why it's squared. So whenever we have to find a normal distribution, we're going to use the mean and the standard deviation, which is the square root of the variance. So remember, we'll just ignore that squared. And if this is the variance, we're going to square root it in order to get our standard deviation. And what we do is we use the area of the curve to find the probability. So our curve follows that normal distribution. We have that bell-shaped curve. And we can use the area of this curve to find the probability, because we say that this entire area under the curve that we have will always equal to 1. And because of that, it means that wherever we find our value for x, we can read off of a table to find the probability being less than 1 based on the area that it takes of the curve. Okay, so we're going to use a standard curve in order to read our table. And when we have the standard curve, okay, directly in the center of that curve, that will be the mean that we have. Then the standard deviation is how far away something is from the mean, okay? But on a standard curve, this mean is 0, which means anything to the left on this side is going to be negative, and anything to the right on this side is going to be positive. Because the standardized curve, if that's 0, it means below that is negative, above that is positive. And once the curve is standardized, then we've got to learn what we must do to the curve in order to be able to read it off the table. Okay, because we cannot just read negatives off the table, and we cannot read to the right of the table. So when the Z value, which we use for the standardized table, okay, is given to us, it must always be positive, and the area must always be to the left. So every value on the table is showing us the probability that is positive and to the left of our Z line. So when it's not positive and to the left, it means we have to change what we're going to be looking for. So if we look at some examples, we have got the probability that Z is less than 0.85. Okay, so if that value there is less than, it means if I draw the curve that I'm looking at, okay, 0.85 is a positive value. So if this is 0, positive is going to be there. Okay, so let's say that's my 0.85 because it's on the positive side. Now the Z must be less than. So now because it's less than, it means it's everything that's smaller than 0.85. So smaller than would be all of this area over there. Okay, so now I have a positive value, and I'm looking for the area that is to the left of that value. So those are the criteria that I want for the table, because it's positive and it's to the left. So now I have a table that looks like this. and it's got Z values on it. So the first thing I do is I look for my value in the first column going down for the first two numbers. So my first two numbers are 0.8. So I look down that Z and I find 0.8. Okay, so I look at this line of that 0.8. And then I look for my next number. So the next number is 5. So then I look across the top and I find 5. And then I go down to find the value that I'm looking for at 0.85. So that value is that one over there, which is going to be 0.8023. So there, my answer for my probability is my 0.8023. So that's how we use the table to find our probability numbers. So if I look at the next example, so now I have Z being greater than 1.377. So now if I looked at the curve that I had, 1.377 is positive. So it's going to be on this side. Okay, because remember the middle is 0. So if it's this side, but now this means greater than. So if it's greater than, it means it's got to be everything bigger than that number, which means it's going to be over there because it's everything above that. So now, okay, my value is positive, so it does meet the 1 criteria, but I'm looking for the area to the right and not to the left. So now, because on my table I can only read areas to the left, if I wanted this little bit here, remember this entire area adds up to 1. So if this is 1, and all I want is that little bit, I would say 1 minus all of that other area that I have, because everything else over here to the left is going to make this total be 1. So I can say 1 minus my value that I have for that, because I will then get this value. And if I say take that away from 1, what I'm left with is just the area that I want. So I say 1 minus my 1.377. Okay, and now whenever we are looking at these values on the table, we always indicate that we are looking them up using our Greek symbol for phi. Okay, so we say 1 minus what we're looking up on the table, which we represent with that little symbol. So that means I can say 1 minus, and now I look up 1.377 on the table. So if there's my table, now I'm going to find 1.3 as my first values. Then my second one is 7. So now I look across the top and I find 7. So now I have 1.37, okay, as 0.9147. Now there's another 7 there. So the last number, I need to then look at these little values on the side, and I find 7. And I go all the way down, okay, and where the 7 is, it says 11. But you see it says add. So what this means is I'm going to add this number to the last few digits of the number inside the table. So my value is 0.9147. So to the 47, the last digits, I'm going to add 11. So 47 plus 11 makes 58. So now my value is 0.9158. Okay, so anytime you're looking at these last digits in there, you add whatever this number is to the last digits of that. So there I have got 1 minus 0.9158. And if I type that in my calculator, my probability is 0.0842 for just that area on the curve. Okay, so if it's positive and to the left, you read it off the table as it is. If it is positive and to the right, you say 1 minus your value that you read off the table. Okay, and then if you look at the next one, now I have got the probability that z is greater than a negative number. So on the curve, remember 0 is in the middle. The negative number is now going to be on this side. So now I have negative 1.377. And I want everything greater than that. So it's all the numbers higher than. So it's everything there to the right because it's greater than my negative number. Now, the z value must always be positive. So whenever I have a situation where I've got a negative now, the thing I have to do is I have to flip the curve. So if this is my curve, I take it and I flip it over. And if I flip it over, I'm going to get a new curve. And where that negative was, it's now going to be positive. Okay? And everything that was going to that side is now going to be on this side. Because I took this value and I flipped the curve around. And now I've got that. So now that I've flipped the curve, now I can see that now the value is positive. And I want everything to the left, which means this meets my criteria. So I can then say, I just want my value of 1.377. And that's the same as the one I just looked up. So I know that it's 0.9158. So that would be my final answer. Okay, so now if I look at my last example on this page, I've got my z being less than my negative number. So I've got my curve with 0 in the middle. I've got negative 0.85. And I want everything less than that. So everything that is less than is now going to be on that side because it's going to be everything keeping smaller. Okay, so now I have got a negative number and I want the area to the left. Okay, but remember my z must always be positive. So the first thing we want to do is we are going to flip the curve. So I'm going to take that and I'm going to flip it over, which means it's now going to sit on this side. And everything that was there is now going to be over there. Okay, so now I've got a positive number, but now my area is going to the right. So just like I did here, when it's going to the right, I want to say 1 minus everything to the left. So I'm then going to say 1 minus my phi value of 0.85 to look up. So I've already looked up 0.85 and I found it's 0.8023. So I'm going to say 1 minus my 0.8023 to get my final answer of 0.1977 when I'm adding them up. So you've always just got to look at, do I want less than, greater than, is it positive or is it negative? And then you're always going to do the same thing with the curves of either 1 minus or just reading it off the curve that you want. Okay, so the other things that we could possibly get with our curves is that sometimes we want values in between. So here I want when it's greater than one number and less than another. And when this happens, we're going to do the same thing for reading off our table. But now, for example, here I want greater than 0.5 but less than 2. So if I drew a curve with my 0 in the middle, I've got 0.5 and I've got 2. And I want where it's greater than the 0.5 and less than the 0.2. So I want everything in the middle over here. So I want an area in between two things. So in order to do that, it means that I still need to follow my rules of being positive and taking everything to the left. So now, where these values are, they are positive. But if I took the answer for 2 on my table and I read off 2, it means I'm going to get all this area of everything there. The entire thing. But now I need to stop at 0.5 because this area is actually not supposed to be included. Okay, so if I read off my value for 2, okay, that would give me all of it. But now I don't want this little value. So if I read off the 0.5, okay, because if I read off 2, it means I want all of that. But now 0.5 will just give me all of this area from there downwards. Okay, so if I minused that area from the total area of the space, all I'm left with is the area I want. So I can say that I'm going to take my 2 from the table and I'm going to minus my value that I look up for 0.5. And that will give me just this area that I want. Okay, so if we look on the table, I want 2 as my first value. So I find 2.00 because 2.00 is the same as 2. So there my answer is 0.9772 for my first one. So I'm going to say 0.9772 minus my value for 0.5. So now I find 0.50 because 0.50 is the same as 0.5. And I get my answer of 0.6915. So there I say minus 0.6915. And when I type that in my calculator, my final probability is 0.2857. Okay, so if we look at the next one between, so now I have Z being greater than negative 1.4 and less than negative 0.6. So if I look at my curve where I've got 0, now my values are negative. So I have negative 1.4 and I have negative 0.6. So I want everything greater than 1.4, which means everything this way, and everything less than negative 0.6, which is that way. So I want everything in between there. Okay, so now I've got areas in between, but the first thing I notice, they're negative, and I cannot have negative on the table. So the first thing we have to do is flip the curve. So I'm going to take my curve and I'm going to flip it over. And when I flip it over, it means I'm going to get my 0.6 and my 1.4 that are positive, and I still want the area in between. So now I want that space. Okay, so now it looks very similar to the one I just did. Okay, because now I've got my 1.4, and if I read that off the table, it would give me the entire area. So it would give me everything from 1.4. But I want to exclude this area here. So now to exclude that, if I subtracted 0.6, it would give me all of this area. And then I would be left with just that. So I want to say that I'm going to look up my value on my table for 1.4, and then I'm going to subtract my value for 0.6 to be left with just the area that I want. So on the table, I find 1.40 to get 0.9192. So I'm going to say my value for that is 0.9192. 2 minus my value for 0.6. So now I'm going to find 0.6 on the table, and I get 0.7257. So I'm going to say minus 0.7257, and that will give me 0.1935 as my answer. Okay, so then if I look at these ones now, I've got one positive and one negative in between. So I want Z greater than a negative 2.696. So I'd find that my negative 2.696 on this side, but it's got to be less than positive 1.8. So now I say positive 1.865. Okay, so since I want everything greater, I want that. And since I want everything less, I want there. So I want everything in between. Okay, so now if I read for my 1.8, that's positive, and that area is going to the left. So it means that I'm going to want to read off my curve, my value for my 1.865. Okay, now if I read it off the curve, it's going to give me all of this area that I want, but it's also going to give me this area. Now this area I want to exclude. Okay, so this is from my negative 2.696 onwards to the left. I want to get rid of that. So I can see that's on the negative side. So what I normally would have done when it's negative is flip the curve. So there I've got now my 2.696. So where this area was there, now it's going to be there. Okay, and this is the area I want to get rid of, which means that from my final answer, I'm going to minus that area. Because remember, this area I've already got is giving me all of it. So now to exclude that, I'm going to say minus. And now this is on the positive side, but it's going to the right. So what we just said was to get the area to the left on there, from reading off that 2.696, okay, to get just that area to the right, I would have said 1 minus my value of my 2.696, okay, because remember this whole thing is 1, so this 2.9696 is going to give me everything to the left, so 1 minus it would give me just that area to the right. So I'm going to take my positive 1 minus 1 minus my negative 1. Okay, so these are the kinds of things that you just have to learn for what we're looking for on the area of the curve. So now, if I look up my 1.865, so I find 1.8 on there. And then I look across the top and I find 6. So now I have my value of 0.9686, okay, for 1.86. Now my last digit is 5, so now I go to that last column and I go down the 5 and it says add 4. So it means I'm going to add 4 to my last 2 digits there. So I have 86 plus 4 is going to be 90. So my total value is 0.9690. So then I'm going to put that in. 0.9690 minus 1 minus my 2.696. So now I look up on the value 2.6. So I find 2.6, 9. So I go all the way down to my last column. So now it's 2.69, and then my last one is to have 6. So I go all the way down to 6, and it says add 1. So now I've got 0.9964 plus 1 is 0.9965. So then I say 0.9965, and when I type that in for the full sum, I get 0.9655 as my final answer. Okay, and then the last possible kinds of graph work that you can get is here I have a negative value again, so my z is greater than negative 1.96 and less than positive 1.96, but you can see that both of those are exactly the same value. Okay, so what that means is on my curve where I've got my 0, there I've got my 1.96, and there I've got my negative 1.96. And I want everything in between because it's got to be greater than and less than. Okay, so my values are the same. So now just like I did there in my one next to it, okay, where I had my positive to my negative, I'm going to take my positive value. Okay, and then I'm going to subtract where I had the negative space that I want to get rid of. Just like flipping the curve, that area there, I would have said 1 minus. So I'm going to say 1 minus my 1.96 value. So now if I look at that, what that is saying is I've got my 1.96, okay, and if I put the negative into the bracket, that's minus 1, but negative and negative means that's plus my other 1.96 minus the 1. So now that plus that is the same as saying 2 times my value minus the 1. So whenever you see that you have both the same value, but one is positive and one is negative, you can just say it's going to be 2 times that value off the table minus 1. So if I look at that table, it means I'm going to have 2 times 1.96. So now I look up 1.96. So 1.9, I find it along there. And then 6, I get 0.9750. So I've got 0.9750. Okay, 2 times that minus 1 gives me a final answer of 0.95. Okay, so those are the kinds of graphs that you're going to be looking at and researching. Okay, to look it up on the table to find your probability value. But these were all when Z was already standard, okay, because we look up Z on the table. But in your questions, the first thing you're going to be given is X, okay, because we're going to be dealing with variable X. So before I can even look at the tables like these, I have to know how to standardize my X value and turn it into Z in order to look it up on the table to find the probability. Okay, so that's what I will look at in the next video, is how we standardize Z. But you must still remember all of these different examples from the graphs so that we know what we're looking for when we need to 1 minus, when we need to keep it as it is, so that when we're looking up on our table, we always get the right probability value.